Hello everyone, in response to a viewer's request, I'll be sharing with you some easy tips to sketch exponential and logarithmic functions such as this, or this. Now when we see the word sketch, we don't need to plot out the graph exactly to scale, but we need the essential information of the graph. Now things that are essential would include the shape or form that the graph takes, the x or y intercepts, the asymptotes, and the labels, such as the name of the function and the x and y axis. So let's zoom into the first example. An exponential function that you see over here. Sketch y equals to e power x, where x is a positive number. Now, since the x value is positive, the basic shape or form that the graph takes will come from the positive x region down to a negative x region. Now make sure that the drop over here is steep. Now we come to tip number 1. Always remember this basic form of the graph. Now this is the basic form for e power positive x. If you can't remember, not to worry, or if you are stuck in the examinations, we come to tip number 2. Substitute extreme values of x into this equation and you can see the rough shape of the graph that it can take. So if we substitute x equals to 15, for example, we have y equals to 3269017.372472111, and this is a huge number, and this indicates that the graph starts from a very high point in the first quadrant. Substituting the extreme end, for example, such as x equals to negative 15, we have 0.00000305902321. What a mouthful. This means that the graph will taper down towards y equals to 0, but doesn't touch it. Now tip number 3, substitute values such as x equals to 0 or y equals to 0 into this function. And this nicely lands us into the second part, which is to find the x and y intercepts. For this case, when x is equals to 0, y is equals to 1. If y is equals to 0, the function is undefined. And now this brings us again to the next part of the sketch, which is the asymptote. Since the function is undefined at y equals to 0, the asymptote of y equals to e power x is at y equals to 0. So there you have it. We label the graph, and this is the sketch of y equals to e power x. Now remember, in tip number 1, always remember the basic shape or form of this exponential equation. Now if we do this, we could get y equals to e power negative x easily. In this case, as this is a negative x, the graph comes down from the negative x region down to the positive x region. Or simply put, if there is a minus in front of this x, this graph is simply a reflection of e power x in the y-axis. Now again, if we remember the form of the graph, we can tackle these other questions easily. Now tip number 4, x is a naughty student while y is a good student. In this case, there is a plus 2 to the x value. The x value is now affected. Now remember, x is a rebellious student. If the x value is affected, it goes in the opposite way you want it to. So a positive 2, instead of going to the right, will cause the graph to shift back by 2 units in the negative direction. The y-intercept will now be e power 2, but the form of the graph still remains the same, and the y-asymptote still remains the same as well. Now in this case over here, 2 is affecting the y values in the function. So if it's a positive 2, the graph will shift obediently by 2 units in the positive direction. Now this is what I meant by x is naughty while y is obedient. Thus, the y-intercept moves up by 2 units and the asymptote moves up by 2 as well. And similar to case 1c, the form of the graph doesn't change. That's why it is so important to remember the basic form of e power x so that we can have a rough sketch of how it is like. Now let's move on to sketching a lawn graph. Now a lawn graph is basically a logarithmic graph with base e. Now let's try y equals to ln x. The graph will come down from the positive region of x and down towards the y-axis. Notice that the gradient here is quite gentle, so take note if you sketch the graph. It has an x-intercept of 1 and an asymptote at x equals to 0. Now that is why ln 0 or any 0 that comes after a log doesn't exist. Again, following tip number 2, if you are not sure of the form, simply substitute some values of x into this equation and you'll get a sense of the shape or form of the graph. Now let's try ln minus x. So it is a negative x, so it comes down from the negative region down toward the y-axis. The x-intercept is now x equals to minus 1 since it is a reflection of the original graph. Labeling our asymptotes and graph, we will complete this sketch easily. Now let's take a look at other examples to solidify our understanding. Now we have an x plus 1 now. Notice that plus 1 is affecting all the x values as it is within the brackets. So this will cause the graph to shift in the negative direction instead of a positive one because x is a naughty student. And so it is a case for the vertical asymptote of x. Now in the next case, there is a negative 1 to the x values, and this again causes the graph to shift in the positive direction. Now for the next case, it is actually similar to case 2c, just that the plus 2 over here affects the y values of the original graph. So the whole graph shifts up by 2. Now be a bit careful over here, the x-intercept will now be different. So to get that x-intercept in exact form, simply substitute y equals to 0 and we can easily get e power minus 2 minus 1. Now if you are able to remember the basic form of the graphs for ln x, you'll be able to sketch the graph for other log functions as well with different bases that are given to you. Now check out some of the various examples of the log graphs over here. Now I do hope you have learned something from this video. If you have any questions or comments, feel free to write them down in the comments box below, and thank you so much for watching.